Stoichiometry is the mass relationship between substances in a reaction. The mole ratio is the ratios between the substances, and we use the coefficients from the balanced equation to represent the mole ratio. So if we look at this reaction, we have 2 aluminums, so we'll need to multiply by 2, 3 oxygens and 2 oxygens, so we'll need to make them both 6. But when I put the 2 there, that changes my aluminum to 4, so I'll need to go back here and change that to 4. Now it's balanced. So if I pick 2 substances, let's say aluminum oxide and aluminum, I can set up a mole ratio using the coefficients. So for every 2 moles of aluminum oxide, I'm going to form 4 moles of aluminum. If we look at aluminum and oxygen, for every 4 moles of aluminum that is produced, I will have 3 moles of oxygen produced. For aluminum oxide to oxygen, for every 2 moles of aluminum oxide that we use, we'll have 3 moles of oxygen produced. An ideal stoichiometry calculation, we use the balanced chemical equation to give us the mole ratio, and then all calculations are considered theoretical, or your theoretical yield. It's the maximum amount of product, so it's the maximum amount that can be produced. So all of our calculations are theoretical. In theory, how much we should get. So there are 3 steps. First, you're going to convert the given to mole if it's not already in moles. Then you're going to use the mole ratio to convert from one substance to another. And then you're going to convert to the unknown unit. Remembering from our unit 2 that molar mass goes with grams, 22.4 goes with liters, 1 goes with mole, and Avogadro's number goes with everything else. So the element lithium and oxygen react explosively to form. So because we have the words to form, I know that all of my compounds coming before that would be my reactants. Lithium, and means plus, oxygen. Now lithium is not one of our 7 diatomics, but oxygen is, so I'm going to need to put an O2. They react explosively to form lithium oxide. So if I cross my charges, lithium oxide is Li2O. So I'll need to balance it. 2 oxygens, 1 oxygen. It gives me 4 lithium, so I'll need a 4 over there. Then I read the question again to get the math. How many moles will form if 2 moles of lithium react? So my given is 2 moles. And I'm looking for how many moles of lithium oxide will form. So looking at my reaction, underneath lithium, I'm going to write 2 moles. And underneath lithium oxide, I'm going to put a question mark, moles. So then we draw our table, and we start with our given, 2 moles of lithium. Now the first step is to convert to moles, but I'm already in moles. So the second step is to convert to our unknown. So I put moles of lithium, our given, on the bottom, moles of our unknown, lithium oxide, on the top. This is my mole ratio. So I use the coefficients, 2 and 4. And then I simply multiply the top, 2 times 2, divided by the bottom, divided by 4, and that gives me 1 mole of lithium oxide. When nitrogen and hydrogen react, they form ammonia. So they form would indicate the arrow. So everything that comes before that is my reactant. After that's my product. Nitrogen, and is a plus, hydrogen. Both of those are elements. Both of them are in Hofbrinkel, or part of our diatomics. They form is my arrow. Ammonia, which is NH3, is my product. So to balance it, I need 2 nitrogens, which means I need 6 hydrogens. Then I read the question again. How many moles of hydrogen is necessary to react with 5 grams of nitrogen? That's my given. How many moles of hydrogen would be my unknown? So underneath nitrogen, I'm going to write 5 grams, and underneath hydrogen, I'm going to put question mark moles. So I start my table with my given, 5 grams nitrogen. First thing I want to do is convert that to moles. So grams of nitrogen to moles of nitrogen. 1 goes with moles, the molar mass goes with grams. Well, nitrogen has a molar mass of 2, but I have 2 nitrogens, so that's a molar mass of 28. Then I'm going to use my mole ratio. Moles of nitrogen and I'm trying to find hydrogen, so hydrogen would go on top. Use the coefficients 3 and 1. Because I'm looking for moles, this is where I can stop. I don't need to convert to an unknown unit. So then I'm going to multiply, divide, multiply, divide. I only need one significant figure, so my answer is going to be 0.5 moles of hydrogen. Alright, and this one, it tells me that it is a combustion reaction because of the word combusts. So I know that my hydrocarbon has to react with oxygen to form carbon dioxide and water. So to balance, I need 3 carbons, 8 hydrogens. That gives me 10 oxygens on this side, so I just need to put a 5 there. Then I can read the question. 20 grams of oxygen is my given, and my unknown, how many moles of carbon dioxide? So underneath oxygen, I'm going to put 20 grams, and under carbon dioxide, I'm going to put question mark moles. So I start with 20 grams of O2. First thing I want to do is convert that to grams. Convert the grams to moles. So I'd put moles on the top. 1 goes in mole. Grams is the molar mass. So 2 oxygens, 16 and 16 is 32. Then I use my mole ratio to go from oxygen to carbon dioxide. Coefficients 3 and 5. Multiply and divide. Multiply and divide. I need one significant figure, so my answer is going to be 0.4 moles of CO2. Here the problem tells me that water decomposes. So I know it's a decomposition reaction. My reactant is water. Water will decompose into the elements hydrogen and oxygen, both of which are diatomics. So to balance it, I need to put a 2 there and a 2 there. Then if I continue reading the question, I'm given 30 grams of hydrogen, and I want to know how many grams of oxygen. So underneath hydrogen, I'm going to put 30 grams. Underneath oxygen, I'm going to put question mark grams. First thing I want to do is convert grams to moles. 1 always goes with mole. Grams is the molar mass. Well, 2 hydrogens have a molar mass of 2. Then I'm going to use my mole ratio to go from hydrogen to oxygen. Coefficients 2 and 1. Now I'm looking for grams, so now I need to do one more step and say that 1 mole of oxygen and then the molar mass of oxygen. So 2 oxygens have a molar mass of 32. So then I'm going to multiply and divide, multiply and divide, multiply and divide. And I need 2 significant figures, so 240. The 0 is not significant because there's not a decimal. Grams of O2. Here they actually gave us the balanced equation, so I don't need to worry about doing that part. I just need to read the question to find out what I'm given and what I'm looking for. So I'm given 4,897 grams of Zn, and I'm looking for the mass of SO2. So underneath ZnS, I'm going to put 4,897 grams, and under SO2, I'm going to put question mark grams. So the first thing I need to do is convert to moles. So 1 mole of zinc sulfide, and then I need to find the molar mass. So I look at the periodic table, and I add the masses together. 97.5 grams. Once I convert to moles, I use the mole ratio. Moles of given on the bottom, moles of what I'm looking for on the top. Coefficients 2 and 2. Now I want grams, so now I'm going to say 1 mole of SO2 is 64.1 grams of SO2. And then I'm going to multiply and divide. Now we're starting with a number that's in the thousands, so we're going to end with a very large number as well. I need 4 significant figures, so 3,219 grams of SO2. Okay, in this problem it doesn't tell me the reaction, however it does tell me that hydrobromic acid reacts with magnesium. So reacts with is my plus sign. So hydrobromic acid, HBr, plus magnesium. So that's a single replacement reaction. A metal is reacting, or is going to replace hydrogen gas in an acid. So using my reference tables, I know that magnesium would go with bromine, so I'd cross my charges and get MgBr2, plus hydrogen gas, and hydrogen's a diatomic, so it has to be H2. And then I'd have to balance it, so we put a 2 there. To read the question, I'm given 2.43 liters of my acid, and I'm looking for liters of hydrogen gas. So underneath my acid, 2.43 liters, and under hydrogen gas, question mark liters. So the first thing I want to do is convert to moles. So there's 22.4 liters of HBr in 1 mole. 22.4 always goes with liters, no matter what. Mole of HBr to mole of my unknown H2. I use the coefficients 1 and 2. Then I need to convert to liters. So 1 mole of hydrogen is 22.4 liters of hydrogen. Doesn't matter what it is, liters is always 22.4. So then I multiply, divide, multiply, divide, multiply, divide. I need 3 significant figures, so I get 1.22 liters of H2. When fluorine gas reacts with, remember reacts with is plus, so I need to write my reaction. Fluorine is a diatomic, so it's F2. Potassium chloride, cross your charges, KCl. So it's a single replacement reaction, and it's a halide-halide reaction. So potassium will go with fluorine, and I'd cross my charges, and then I'd have chlorine by itself. Now chlorine is a diatomic, so it'd be Cl2. To balance it, I would need to put 2 and 2. 0.425 liters of potassium chloride is my given, and I'm looking for grams of chlorine gas. So underneath potassium chloride, I'd put 0.425 liters, and under chlorine gas, I'd put question mark grams. So 0.425 liters of KCl. First thing I want to do is convert to moles. There's 22.4 liters in 1 mole. And then I use my mole ratio to go from potassium chloride to chlorine. Coefficients 1 and 2. Now I want grams of chlorine, so now I'm going to go from moles of chlorine to grams of chlorine. Now it's Cl2, so 35 and 35 make 71 because it's 35.5. And then I would multiply and divide. I need 3 significant figures, so I get 0.674 grams of Cl2. Here they gave me the reaction, but I would need to balance it. 2 irons, 1 iron, so I multiply by 2. 3 oxygens, 1 oxygen, I'd put a 3 there. That gives me 3 carbons, so I need to go back and put a 3 there. I'm given 2.4 moles of carbon, and I want to know the volume of carbon monoxide. So underneath carbon, I'm going to put 2.4 moles. And under carbon monoxide, I'm going to put question mark. Now, volume is measured in liters, so we'd put question mark liters. First thing I need to do is convert to mole. I'm already in mole. So then I would want to use my mole ratio. So moles of carbon to moles of carbon monoxide, and then I use the coefficients 3 and 3. Now I want liters of carbon monoxide, so I'm going to say 1 mole of carbon monoxide is 22.4 liters of carbon monoxide. So then I multiply and divide. I need 2 significant figures, so I have 0.11 liters of carbon monoxide. So coal can be converted to methane gas by the process called coal gasification. Keep reading and it tells you the reaction. Carbon monoxide reacts with water, so there's my plus. To form would be my arrow, and would be another plus. So I have carbon, which is not a diatomic, plus water to form as my arrow, methane, CH4, and carbon dioxide, CO2. And then I would need to balance it, taking care of my hydrogen first, 4 hydrogen, so I have to multiply by 2. There's my 2 oxygens, so it's balanced. Oh, I'm sorry, 2 carbons, so I need to multiply carbon by 2 as well. So keep reading the question. How many moles of carbon if I have 1 liter of methane? And I'm looking for how many moles of carbon. So under carbon, I'm going to put question mark moles. And under methane, I'm going to put 1 liter. First thing I want to do is convert to moles. Well, there's 22.4 liters for every 1 mole. And then I use my mole ratio, mole of CH4 to mole of carbon. 2 carbons, 1 methane. I want to know moles, so I'm actually there and I can stop. So then I'm going to multiply and divide, multiply and divide. I want 3 significant figures, so I'd have 0.0893 moles of carbon. How many liters of oxygen are produced in the decomposition of water? So I'm decomposition of water. So water is a substance being decomposed. Water will break down into hydrogen and oxygen, both of which are diatomics. So to balance it, I'd put a 2 and a 2. I'm given molecules of water, and I am looking for liters of oxygen. So underneath water, I'd put 3.01 times 10 to the 23rd. And under oxygen, I'd put question mark liters. So I start with my given, molecules, water. First thing I want to do is convert to moles. Remember, moles and molecules are not the same thing. So for molecules, we would use Avogadro's number, and that is 1 mole of water. Now I can use my mole ratio to change from water to oxygen, coefficients 1 and 2, and then I want liters, so I'm going to say 1 mole of oxygen is 22.4 liters. Make sure to use the special button with the times 10, multiply and divide, multiply and divide, multiply and divide. I want 3 significant figures, so I'd have 5.60 liters of O2. So here it tells me combustion. So I know this is a combustion reaction. So I'm going to take my hydrocarbon, add oxygen, and that's going to give me carbon dioxide and water. Balance my carbon first, then my hydrogen. That gives me 4, 5, 6, 7 oxygens. Well, half of 7 is 3.5, and you're not allowed to have 0.5, so now I'm going to multiply all my coefficients by 2. And we're balanced. Read the question. I'm given 1.25 moles of water, and I want to know how many molecules of ethane are used. So underneath water, I'm going to put 1.52, and under methane, I'm going to put question mark molecules. Remember, molecules and moles are not the same thing. So I start with my given moles of water. I'm already in moles, so I can jump to the mole ratio. Moles of water to moles of ethane. Coefficients 2 and 6. And then I want molecules, so I'd say 1 mole is Avogadro's number of molecules. And then I would multiply and divide, remembering to use the special button for the times 10. I need 3 significant figures, so 3.05 times 10 to the 23rd. Make sure you check your calculator there. Molecules of ethane.